Okay, welcome back. For this session, we're just going to follow through on the practical application of that co-integration test. So as we said, that unit root test is a simple unit root test. It's even simpler than focusing on one single variable. It's only that when we get to calculating the critical values, it becomes a little, there's a different set of critical values, because what matters is not only the sample size, but also whether we focus on a single variable or a linear combination of two variables. And furthermore, does this regression, the underlying model that we're interested to see whether those two variables co-integrate, we look for answers in that residual. And if there goes linear combination of two variables into the residual, then n is equal to 2. So there's the formula as we've seen. And we're going to plug in, we're going to go to the table, look for n equals to 2, and if we're interested in the 5% critical value, we will plug those values in there together with the number of observations in our regression, in this regression. And if one of the series have 40 observations and that one has 38 observations, T is 38, because the two of the observations will be dropped. So this is the example where we have two variables. We see that we have just an intercept, so we come here, and then if we want to calculate the 5% critical value, that is what's plugged in behind the scenes. Here for a 3-variable model, we come here, and again, we see no trend in here. So we come here and we calculate the critical values. And if it's only one variable, we plug those values in. So the question is, as a practical application, if we look at the simple Keynesian consumption function, that is literally about the only relationship I can think where only two variables matter. So that residual, we can clearly observe some zero correlation going on there, which is very typical for series that's trending like that. So just looking at that, it looks like maybe we're still missing something. Maybe we're not there yet. Maybe it's wealth effects, maybe other things that we want to include. Maybe it's not as simple as the Keynesian consumption function, but we want to go to the permanent income hypothesis and test that, which is a little bit more difficult. In practical applications, what is then used is household wealth to approximate that idea of permanent income. So looking at that, does that really look like a co-integrated relationship? Because we said they should move and that distance should remain fairly constant, and now it moves closer together. And also consumption is above income. That almost feels wrong. On a national level, we can consume more that is registered as income. And the national accounts do make provision for the informal sector. So, you know, that's already prompts us to think why from this early 2000s, it behaves in that fashion. So, but that's a different question altogether. The question is, of course, that consumption is probably that there is more income that's not really accounted for. That shows up as consumption, but it doesn't reflect on the disposable income side. So the question is, statistically, are those two variables performing the tango? It doesn't look like that. How we do it depends on which software we use. Mostly it will be a command to test for co-integration. In this, maybe I can just open it here where it's a little bit larger. So I have consumption and income. Those two variables, I can open them as a group, and what we saw here is that. So the question is, view co-integration test, and then there we have the multivariate. Here we have the single equation. The bounds testing approach, it falls under ARDL. It's not an OLS application, so we access that differently. So if we go here, what do we need to complete here? Nothing. We just can hit enter, because what happens here, it's the Engel-Granger stat. We will again use the Schwarz criterion to correct for zero correlation, to determine the number of lags in the augmentation, and that constant. Let me just show you what are our options there. It's constant, none, linear trend, quadratic trend. Constant is the default, but what does that mean? Does that mean the test regression is an intercept model? Or does it mean, what does it mean?
Prof, please enlighten me here. Yeah? I need to understand whether it's important for us to specify the number of legs, say like I put 5, I put 10, or maybe I should leave that.
Leave that for the model selection criteria. I think that is the most clever way of doing it.
Because if I specify it, it might cause,
With R, we have to, there's one test in R that can use model selection criteria, but unfortunately, the authors implement it that way. They will test down, and even if it should be 0, they will put 1 lag. It's like, but let me give you something. Let me give you.
Some assumptions.
It makes it difficult to match results in two softwares exactly. Yes. You do specify, use the Schwarz information criterion, but then they will test down, and if they find 1, the results will match exactly, but if they find 0, they will put 1. And that, it's just a little thing, but as I said many times, that will not really change the outcome, your conclusion. It will just change that little number, but it will not change your decision that much. So this constant here refers to the constant in Can I move this? The constant that we select there refers to our underlying relationship if that contains a constant. It's not a constant in the test regression of the unit root test. But typically, it's almost that we don't have to worry over that, because we will almost in all cases have a constant in our regression. And then if we click OK, now eViews is a bit stingy with the information. It doesn't give the critical values here. It skips that step and only shows the p-value. because we don't really need those critical values. But it could have been helpful to compare if it showed it to us to see that it's different than for the variables individually. So read the English. We're testing for co-integration between income and consumption. The null is no co-integration. We run a regression, we run this regression, we save that residual, we now perform a unitary test on that residual, so that is the tau. On the test regression on that row star, that's the tau. And it's just a tau, not a tau or a tau mu. And associated with that is this probability. So that skew distribution to the left, the critical value was to the right, the 5% critical value was to the right of, that value, and the 1% critical value was to the left. So what happens there, if I can maybe do a little bit of a, have a little bit of a whiteboard here. So we regressed consumption, but let me just do it the right way around, because obviously now we will have to look at this value. I wasn't careful selecting that, so we select consumption. We always select the dependent one first and then the independent one. Otherwise you have to look at the second line. We view co-integration test, single equation. We say okay. So since consumption is the dependent value, our interest is there. And what happened in the background? We regressed consumption and income, we take the residual, and that residual we performed a unitary test, and now we're looking at this. And the test stat here is minus 3.50. So we don't know what the critical values are there. It's just not shown to us. But what we can say is based on that p-value, that this area to the left of the statistic is 4%, 0.0430. So that's the probability of a type 1 error. So we know that the critical values, although it's not shown to us, it may be that the 1% critical value is minus 3.68. And the 5%, so the 1% will be there, the 5% will be close, actually closer. So say it's minus 3.42 or something. So all that we really need is the probability here. We don't really need the critical values. The premise is this will be an oversharing of information. You don't know to know that. We just give you the p-value and that's enough information. So, despite the fact that the trend of the variables didn't look co-integrated, statistically, that distance for that whole period, maybe the fact that most of the sample period, the distance was quite constant, and then it moved closer together, but that's not enough to conclude we now don't have co-integration. Does this make sense?
Yes, Dr. Hu?
I would like to ask you, in terms of the community, can I also use the one for Z statistic?
So,
I guess we have two communities. Can I also use the other one?
I I once looked it up. Normally the Z-stat is for large samples, right? I think in this case there's a slight difference from that. We just have to look it up again. But we just used to report that one, but certainly it almost never give a different result. But there's a little bit more to it than just being that large sample statistic. But the one that you will see reported in the papers and the one that R will give, actually R will not give you a p-value. There's a little bit of labor to do. It will give you this stat. So how about if we don't get co-integration at first glance, but maybe let me just follow through and then we look at one or two examples. So the idea, you may wonder, why do we even see that line? Again, it is like to bring it closer in line with the multivariate co-integration that is based on the fact that everything can basically cause everything else. So if we would have put consumption on the left-hand side, so this will be the test on the error of consumption as a function of, income as a function of consumption. If we put income that side and consumption that side, and take that error. Asymptotically, these values should be the same. And in this case, since we have a fairly large sample, we indeed see they are very similar. But an example that I'll show you just now for money, if you have money as a function of income and interest rate, you get different results if you put money on the left-hand side versus income and versus interest rates. So when you write this up, this is all that you need to report. We don't need to start arguing what's the case when income is a function of consumption. This is what we do in running a regression like that. You've already taken the decision to normalize on consumption. Even though there may be feedback effects, but this is one example that we believe that income is indeed a causal factor for consumption. And yeah, these are things that we know. That is a t-stat, but it's also not fully distributed. We now have the same as for a single variable. We have to use more a different set of critical values. The p-value is based on that calculation for two variables, and what we conclude here is that straightforward, we fail to reject the null. We reject the null of no co-integration at the 5% level. And then you can move on to build your ECM, or maybe that's all that you're interested in, to say something about the marginal propensity to consume. How this is different. For example, if I do it manually, if I regress consumption and income, save the residual and perform a unit root test, look at that p-value. How is it different from this p-value? This is the correct p-value for n equals to 2. If you just treat that as a normal variable, you will work with these critical values that we worked out from that table for n equals 1, and they are wrong. And this is unfortunately then what R gives us. So until somebody put in the work and put those tables in the package, we have to do the work on the side. So that probability is then wrong. This will too easily make us think we have co-integration, right? So we calculate it from there and not using those 5 parameters. Yes.
Please, could you just come again on the, is it phi 1 and phi 2 on the tables?
Yeah.
What do they represent? Phi 1.
They together are the ingredients of that response surface calculation. That C function of P, which is then phi infinity, minus phi 1 over T, minus phi 2 over T squared. And that is what McKinnon worked out. Those critical values behave according to that response surface. So if you coded these formulas, these will be variables in that formula that you can plug in and solve and get those critical values. So it will just be 3 lines of code and a matrix in the back to work out the critical values. So maybe then, now that I've searched high and low for a package that does it, I will probably now have to make the students write that bit of code, or just sit down and do it. I mean, it's not difficult, but I have not found any of the existing packages. Anyone in that 22,000 packages that did this. And if you come across that, please let me know. But I have now searched, but maybe I've still missed it. I don't know. So there's the idea that the p value is literally enough to know that we in the rejection region. It actually shows us exactly we reject at the 4%, 4.3%. So yeah, these are the same story again. That this is what we do with the Engel-Granger approach. Obviously so simple, but almost too simple to publish a paper with it. You don't see many papers. Maybe if you papers way back in the early 90s, they published papers using the Engel-Granger. But now, immediately, since ultimately many of our relationships will have more than one X. And as soon as you have that, the first line a reviewer will write to you, how do I know you have a unique co-integrating vector? Even like money is a function of income and interest rates, sometimes there's a second relationship going on there, even if it's not a theoretical, economic theoretical relationship, it's a statistical relationship, income and money. Because as the economy expands, we need more money to facilitate the transactions. So literally that tests as a co-integrating relationship. So that is what we want to then avoid. And that is why we also then have the multivariate approach. But immediately I can say the ARDL method is also a single equation, so suffer from the same problems essentially. But if you can add the multivariate approach and perform a co-integration test there and show that the rank of your matrix is 1, that you only have one unique vector, then that doesn't present a problem of having essentially a mix of different unique vectors. So there's still a good way out if you have more than 2 variables, which is we will mostly have at least 3 for macro applications, but more likely more than 3. Apply the ARDL or apply the Engel-Granger, but on the side use the multivariate co-integration test and hope you get one vector, but if you don't get one, then you just follow through with the multivariate approach, but then you have to identify the different relationships. And sometimes it's just acknowledging, yes, there's a second relationship between money and income. And as soon as I account for that, I'm essentially only interested in the relationship of money. So then it just, I don't know what, it dangles along, but you then have accounted for that fact. And I think that is almost, of course, yeah, that's one of the limitation. It's only unique if we have two variables, because they can up to be n-1 co-integrating vectors. So the Johansen approach and Stock and Watson, those are both maximum likelihood procedures, which can then test for multiple co-integrating vectors. This has made it into the literature, especially for when you estimate a system like prices and wages and maybe labor and production, employment and production. These are definitely wages is a causal factor for prices, but prices is a causal factor for wages, and then we can have employment and production there in the system as well. So that's 7 or 8 variables, and then you may want to identify 3 relationships or 4 relationships within that set of data, which make it quite challenging. So early on, there were quite a number of papers modeling, say, the wage bargaining in Germany or the wage bargaining process in the UK. But it's not that every other article that you look at will use the multivariate co-integration technique. And I think this is the end, almost. Yeah, it's saying the same things that I've already said. So the thing is, if we have n variables, you can have up to n-1. And when we start discussing the multivariate, it will mean reduced rank of that alpha times beta matrix. We will discuss that after we've done the ECM for the Engel-Granger method. And that is the last slide. Are there questions? I just want to show 2 examples of what we do if we don't find co-integration. Do you just throw your hands in the air, go home, and find a new, not even a new job, a new discipline to work in? And that is sometimes where we think, yes, the theory doesn't work for our economy because there's so many structural breaks and we can't explain. But then it's simply try a little bit harder. And I just want to show you 2 and you need not even go there. I just show you there's an example on M3 money, And then there's an example on gross fixed capital formation. So I just want to maybe just look at this file and then look at the application. But now I don't even really need to. So just to put this in context, the simple money demand equation, the famous 1936 general theory of, in short, we often say general theory of money, but the title of the book was Employment, Interest and Money. The simple Keynesian function is this. The money, this is the money, real money balance, the broad money typically, M3 money balance in real terms, deflated by the CPI, is a function of income, and that interest rate is taken as the bond rate, which sounds funny, is it not? You think money, would that be the right interest variable? The price, would that, why the bond? Why income? Because we need it. It's a medium for transactions in the economy, precautionary to save, and speculative to try and make the money stock more with each individual and firms and so. And that interest rate is then taken as the bond rate, which then measures the opportunity cost of holding money. Why the bond as an opportunity cost and not any other rate?
Like bond is flexible and is not like affected easily with the interest rate, you know. It's a safest investment that you can ever have as a speculative person, rather than holding something like stock market or other certain shares that can be impacted by certain economic events, you know. For example, what is happening in US, you find that those
It's interesting what's happening. Yeah, all that you say is absolutely true. You actually already suggest the further developments. If we time travel back to 1936, it's like that was an alternative way. If you don't keep your money in the money system, in as demand deposits or cash, the alternative would be to buy bonds. So if the bond rate goes up, that means you then that will actually make people move money out of demand deposits and more liquid forms of holding the cash and put it in the bond market. Yes.
I forgot to mention that most investors, in most cases, they will hold both stock and bonds so that they can perform what is called hedging, so that they can hedge against any risk that might occur.
Yeah, so that is, we can improve the model by taking all of that into account. The general theory of asset demand says, yes, but bonds are not the only form. We can also hold it in terms of equities or luxury, invest it in luxury goods or anything in the goods market. So that will be a better way. And there's one paper that I've uploaded there where we used that. It was just an honest student who estimated this function based on a paper by Stephen Hall and the co-author. It was commissioned work for the Reserve Bank, but I very much like the title of their paper. It was titled, "Where Did All the Money Gone?" Like that song, "Where Did All the Flowers Gone?" Because at some point, the velocity of money was decreasing substantially. And they were asking, what's going on? What's the implications for money demand, blah, blah, blah. And they argued at that point It's because this money demand equation that we do, we don't account for wealth effects, for household wealth effects. So they actually included the health effects in place of this, as Friedman's measure of permanent income or wealth, and then they added all of this. And that paper actually uses the Johansson method. And that student at the time got the, what is this medal? ESA's medal? Founders Medal for the best honors research. So that paper, it's by Rousseau from Van Jaarsveld. He was also one of the guys that went away from the Reserve Bank to Econ Data, but now he's at the head office at RMB. But he did his PhD at Stellenbosch. Also on competition. Who's the competition? Okay, so yes, so that application is there as an example. This one, we just do this. I just want to demonstrate it for this very simple. So firstly, if we estimate that function, this money, as a function of income and the bond rate, which is not the cost of money, it's the opportunity cost of holding money. So if you don't put your money in your checking account or under your carpet, or like some people in the past in their couches or lamps or places, then you can actually earn some interest if you have a bond. So if we just do that first exercise, just doing a unitary test straight on the residual, and that is actually, which one is the money one now? This example. How we get that residual is if you run that simple regression. We know that is the residual. How can we save it to perform a unitary test on it? If you go to procedures and you say make residual, and you can give it a name. If for any reason you need to save that residual. So this is just making sure that is what we think it is. That one is the same as the blue line here down. And if we subject this to a unitary test, and it must be the non-model and in levels. This is the stat on that row star, but we definitely think we have co-integration. Right? That p-value rejects the null of no co-integration. But this is wrong. This is not what we want to do. What we want to do is this is the relationship. They could have put the test here, but they didn't. They didn't put the co-integration test here. What you have to do is to just do the log of M3 money as a function of the log of Y and the bond rate. Open that as a group. Oops. I must just now, I have multiple things selected. Open as a group and now view co-integration. Just like this, that constant refers to this constant here in the underlying equation. And that is now, you can see that the stat is correct. That one agrees with this one, but the probabilities are different. So which one is right and which one is wrong? This one is wrong, and this one is the correct probability. Do we have co-integration? No. Just not. It's just in the margin, just outside of the 10%. So this is now where we go back to this relationship. Look at where we are missing things. And it looks like a little bit here, a little bit around the global financial crisis. And what we see is that actual money was higher than what was justified based on income levels and bond rates. Intuitively, does it feel right that a crisis make money increase? It doesn't feel, but think again.
The supply of money increase.
The money supply, that's money balances. The stock.
In the economy.
In the economy.
It would be a positive.
It should be positive, right? Because in terms of uncertainty, people tend to move to more liquid assets. Uncertainty, if you owe stock at that moment, it's like, ooh, we see what's happening. Let's get out. Put it in a savings account. Put it under the carpet. Keep it as cash, whatever. So that's why we see that increase. So how can we then try again? We can do that test for the multiple break, and it is here. It shows 3 breaks, 86, 94, 2009. So what we do with that is try different things, maybe create a financial crisis dummy, which will be one in 2008, 2009. The impact of the financial crisis already affected our financial sector in 2008, but only affected the real sector in 2009. So this will be that one. So how do we change what we do? We come back here and we select money, income, and bond, open as a group, view co-integration, but then say, let's control for the financial crisis. So we put the financial crisis dummy as a deterministic regressor. Oops, I have selected it incorrectly now. I mustn't select it. And I say that is a... So now, what is this story now, as opposed to just testing those 3 variables? What does the p-value say to start out with? We now do find co-integration once we control for the financial crisis. We don't put it as, we can select it as a variable, but that is not, doesn't really make sense, because if you look ahead in terms of the Christopher Sims reduced form var, VEC-M, it will put financial crisis here as a dependent and say now the financial crisis is a function of our money and our bond rate, which doesn't make a lot of sense. So we definitely want to include it as a exogenous variable. In all of the methods, we can do that.
So, here I see you do two things. You check the results, try to reason why this is the case around those. Then you go back to the linear model to try to determine.
Yeah, I also look at the multivariate breakpoint test.
Yes.
And then sometimes you can go and find a variable. If it's about investment, you can find business confidence to say why investment was underpredicted for a certain period. Sometimes it's simply the best we can do is adding a dummy for those 2 years.
Okay, I just want to be sure that applies all these methods.
Yes.
Try to solve this.
Yes, so you try and tell the story as best as possible, finding co-integration. And it's not that we, in this case, it looks like really missing a variable. A rival model would be the one in Rousseau's paper, also thinking about household wealth, but that's a variable that you have to go to the national financial account and extract the household wealth period by period, and then also add stock price returns, equity returns, and see inflation for the goods market, and model it that way and see what you get. That's a different discussion. The theoretical model specification. If somebody looks at this and say, no, but you have it completely wrong, this is not the model to use, maybe that's not the best model, but this is the principle. The assumption of having your model specification right, that is more difficult than test for co-integration and build the model. I saw a hand.
It's related to, say we were working with climate data, and then there's like a climate shock, for example, but like the one variable, the two variables you're using are directly related to climate, let's say temperature and rainfall. And then for a specific period, like the average like shoots up, or for that year it shoots up.
Yes.
Do we still have to then have a dummy for, like, let's say?
Unless you can have, all these measures for climate change, which would basically be some function of precipitation, temperature growth. If it's abnormal, those will capture most of the impact. But there can be years of this was now really hot and wet and tsunamis and whatever. I mean, yes, then it's out of, perhaps you may need a dummy to account for that. I can't think what else.
We use like volatility instead of the actual.
Yes, and there's even some measures that combine the two of them, the first and the second moment, together with other things. Yes, yeah, that's the art of getting your data to tell the story. Yes. The easy way would be to throw a dummy at it, but that's sometimes the lazy way. Okay, so I think we can. Can it already be break time again? It doesn't feel like it. Huh? Only at 3?
Yeah.
Oh, okay, that's good. Oh, you know what? My watch is just giving me random times. I think it's losing time, so I set it ahead. It now tells me it's 35. Because this is good for me to be on time. But now I want to go on break too early. Let me show you one example and then we go.
Even though I have another question,
Yes.
are you going to demonstrate your answer as well?
Yes.
Oh, okay.
Yes.
And I can reserve the question
Yes.
until you, maybe because you already have answered the question while I demonstrate.
Yes, so what will the question be? Then I can tell you if I will answer it.
Okay, I wanted to indicate that if Johansson has the ability to indicate whether there are
Yes.
2 or 3.
That's the rank test.
Yeah, so is it also possible to know if you have several variables on the right hand side to pinpoint we say for integration is between y and x1, y and x2, or typically not just knowing the number of integrating vectors?
What will help you? What will help you with that? Economic theory.
Oh, okay.
Yeah, unfortunately, that's where the mathematical algorithms cannot be that. We can still see, graphically which variables are trending, but mostly we look towards economic theory. If you decide to include output, capital, labor, other variables that's driving investment and employment, then you kind of know what you're looking for in here. Yes.
That's fine.
Yeah. So you almost think of a system of equations, and then you put all the variables in and you try and identify those 3 equations if it tells you you have 3. Yes. Just one more example, because here we went, so that equation, that long run equation will then basically be this. And there we can see that the parameter is positive. And if we try and interpret that, and then you can think, does it even make sense, is that during the global financial crisis, there was round about an 11% increase in the money balance. So there was about 11% more funds that did flow from less liquid asset to more liquid assets on average during those 2 years. And we can never know, because you need a crystal ball to know if the financial crisis didn't happen. That's just a kind of, it would potentially be 11% lower. I think you can analyze, break it down, and see what happened to all the alternative asset classes to see if we can say something about that. But this is what the result says. If income increases by 1%, money increases by more than that 1%, money balance. And if the bond rate increases, it lowers the money demand, the money balances. And that's the financial crisis. And then we can go on and build an error correction model that will basically be something like this, where we estimate now in differences, and we're going to include the long run here and some other difference variables, and that is it. But I want to show you the investment function and say something about that. And then this will take 5 minutes and then we can break. But now, let me just finish that and then we can break. So if we go to the investment function, what we see here is basically the investment function, again, theoretically, there are many rival models, which is in the simplest sense, income and the unit cost of capital. And the unit cost of capital is a function of obviously the unit cost of capital is a function of the relative cost of capital. That's the real interest rate, the depreciation rate, and even the tax rate, as suggested by the original authors in the seminal paper. So you see many papers using this measure. That capital, that best interest rate for capital, what would that be? Because who are investing? It's basically firms that would invest. So I would say a corporate lending rate or something. But it's a mix of agents that invest. In this case, and that rate was only available to like early 2000. So what I took was the bond rate. This is just an analysis on what we're dealing with, the typical painful. So when we look at this, just the simplest of result, we kind of get what we expect. If we test that for co-integration, we do find co-integration. But what we see is that there's a little bit of an underestimation here and here and also here. So can we do a little bit better? This can be surrounding the financial crisis. This is not COVID. What is happening post-COVID? You sometimes see people that look at balance sheets of big banks and big companies, and they sit on so much cash, but they're not putting it in the investment bucket. They don't say, let us build a new building, or I don't know. It's not buying new computers for all the staff or that. You wanted to say?
No, like I thought maybe you were asking the question in regards to
Yeah, to that.
Well, remember that we have seen some spikes globally when it's come to like the issue of tariffs under the Trump administration, the cuts of funding to a number of African countries. I think that might have some impact toward the appetite to invest in diverse portfolios. And you'll notice that what is happening in these fights and these wars, like sometimes it can discourage investors too,
Yes.
because there's this uncertainty, more especially in the trade.
Yeah, it's absolutely uncertainty of some form. So business confidence, basically.
Yeah, just to add to that, isn't that like a global thing? Like Apple was sitting on like $1 or something like that.
Yeah, so what we would like to see, even though we do have co-integration, shouldn't we put in some form of that uncertainty? Whether it's global uncertainty or it's domestic business confidence. So what we tried here was to say, let's take COVID and then the BER's business confidence index. And even though we already had co-integration, does it not make sense to put that as a long-run driver? You see here, the rules are like, it's a little bit blended, the lines, it's flexible. You can decide to put that in there and just see what it tells us here. The business confidence index is not a massive effect, COVID subtracted investment by roughly 11%. If we do that proper calculation, E to that exponent minus 1 times 100. But I still think that that business confidence index of the BER is not the proper variable, because if you look at the trend of the business confidence index, oops. I don't know if I have this open, but if you look at that BCI, it looks more like a little bit of a roller coaster. It's up and down and up and down. If you look at the South African Chamber of Commerce's business confidence index, you see this is now dating back to I think the most recent one is here. They believe that business confidence post 2005 has actually declined more than what the BER. But obviously you have to look at what are the ingredients, what are the type of questions they ask respondents here. But there's so many, the Bloom and co-authors do a lot of uncertainty, global uncertainty, and it's uncertainty in terms of economic policy, monetary policy, general uncertainty, climate uncertainty, and then for several countries as well.
Sorry, Prof. Would a nice proxy or instrumental variable maybe be the World Economic Forum rankings?
Sure.
That would give you a relative to the entire globe. And
yeah, I mean, that's where the science become an art, where you have to search for things that will help explain what we see. Yeah, not strictly speaking an instrument in the sense of instrumental variables, where you have to proxy, find a good proxy for one variable to address endogeneity, but you mean like an explanatory factor.
Exactly,
yeah. Yeah, so there's where we know the techniques, but how do you knit this garment? Okay, so let's break, and if we come back, then we do the error correction model.